All right, so we're going to do section 5.3. I'm going to have 3 separate videos. The first one for every section is going to be the intro. The second one will be easier problems-ish. And the last one will be a harder problem or more if I think that they are there. So for section 5.3, this is going to be my sample problem. And we're going to cover 3 different theorems. So the first theorem that we're going to cover is going to be rational zeros theorem. Which is not how you spell rational. Hang on. Rational zeros theorem. And we're also going to cover Descartes' rule of signs. So it's not Descartes, it is Descartes. And it's an apostrophe, so the S is silent. Descartes. And it's his, so it's Descartes' rule of signs. And then we're going to do the intermediate value theorem. So the intermediate value theorem is going to be the last part of what we do on 5.3. So first of all, what are we trying to do here? I am trying to find out, this is a 3rd degree polynomial. Okay, the biggest exponent I see is a 3. If I set this thing equal to 0, then I'm going to find, when I solve for x, that's going to tell me everywhere where this polynomial hits the x-axis. Okay, if it's factorable, then we don't really have to do these other 3 things. But I'm going to use something that works so we can see how these 3 things actually inform what we're doing. So first of all, this is factorable. So if I factor this down, how do I factor a 4-term thing? I've got factoring by grouping, so I'm going to pull out what's common on just the first 2 terms, which is going to be an x squared. And that leaves me with an x plus 5. On the last 2, I can pull out a minus 1, which will leave me with an x plus 5. And then what is in parentheses is x plus 5. What is not in parentheses is x squared minus 1. And then those 2, this one is done. Okay, he has an exponent of 1. I can't break him down any further, but I can break this down. So this is the difference of 2 squares. So I've got x plus 5, x plus 1, x minus 1 equals 0. So what we just figured out, this is the the polynomial form. This is the factored form. It's the exact same thing, they just look different. So what are my 3 solutions? This one's solution is going to be a negative 5. This one's solution is going to be a negative 1. And this one's solution is going to be a positive 1. So I know that with a 3rd degree polynomial, this, when I graph it, out of an infinite number of points, 3 of them are going to hit the x-axis. So those things occur at a negative 5, a negative 1, and a 1. Okay, so what does that mean in terms of these 3 theorems? In these 3 theorems, the rational zeros theorem, let's pretend like this is not factorable. So how can I use something? Because instead of me saying, holy cow, this thing can cross anywhere in the whole wide world, then what can I do? Rational zeros theorem says take the last number, and I don't care if it's positive or negative, it's just a 5. So I'm going to take 5 over the first number, which is a coefficient, which is a 1. And that's how I set it up. Then I'm going to find the numbers that I can multiply together to get an answer of 5. So in that case, it's a 1 and a 5. And then what numbers can I multiply together to get a 1? Well, that's a 1. And now here's the fun part. You're going to take everything in your numerator and pair it up with everything in the denominator. And those are going to be your options. So this is why I didn't care he was negative. My options can be either positive or negative. So up here, I don't care that this was negative. Just pull out the 5. So now I can have either positive or negative. 1 over 1 reduces to 1. 5 over 1 reduces to 5. So those are the options I have for where this thing, if it's going to hit the axis in a pretty spot, it's going to be in this pile. So remember, I've only listed 2 numbers, but there's actually 4 of them sitting there. So this is a positive 1, a negative 1, a positive 5, and a negative 5. Now, what did we just learn? Come back up here because I already know the answers. What are my answers? Negative 5, negative 1, and 1. Is negative 5 in your pile? Yeah, it is. Is negative 1 in your pile? Yes, it is. Is 1 in your pile? Yes, it is. So this will tell you, this will give you a launching point where if it's not factorable or easy to break down, we can use rational zeros theorem and say, hey, let's try these numbers. Okay, Descartes' rule of signs, we're just going to look at sign changes. Okay, it's going to tell me how many positives to find and how many negatives to find. So I'm going to rewrite this thing, or I'm just going to look at it up here. If I have a positive x to the third, that is a positive term. Positive 5x squared, negative x, negative 5. So now when I count my sign changes, I'm positive, I stay positive, but now I'm positive and I change to a negative. Oh, I'm negative and I stay negative. I had one sign change. Okay, so for positive answers, I am looking for a single positive answer. So this is not the answer. This is how many you're looking for. So come back up here. I already know my answers. My answers are negative 5, negative 1, and 1. How many positive answers did we find? We found one positive answer. It just happens to be positive 1. So this will tell you how many positives to look for. Now we're going to do the same thing, but with negatives. So here's what I'm going to do. Look at your coefficient here, which is still, I got a positive term, negative term, negative term. But wherever there's an x, I'm going to shove in a negative and see what happens. So this is a positive 1 and then a negative to the third power. This is a positive 5 and a negative squared. So I'm just tracking this. This is a negative 1 with a negative x, and this is just a negative 5. I can't fix him. So what is a negative cubed? A negative cubed is going to be negative. What is a negative squared? He's going to be positive. Negative times negative is positive, and I can't change him. He's negative. So this term, if I shove in a negative x value, my first term will go negative. If I shove in a negative x value, my second term will be positive. If I shove in a negative x term, my third term will be positive, and then my last term is negative. So how many sign changes have you got? I changed, I stayed, I changed. So for negative answers, I'm looking for 2. I am looking for 2 negative answers. I have the answers up here. So I have found 1 positive, and I found 2 that are negative. Now here's the trick. Okay, this is what's going to rip your face off. Your trick is you always have to count backwards by 2s. You're telling me a quantity. So I don't care if there's 0 of something, and I don't care if there's a negative amount of something. So why am I, well, I do care if there's 0. All right, so I've got a positive 1 here. Well, if I count backwards by 2s, I'm going to get a negative 1. So he's done. On this one, I have a 2. Now count backwards by 2s. So 2 minus 2 is 0. You always count backwards by 2s. So here's what you found out. I'm either going to have 1 positive and 2 negatives, or I'm going to have 1 positive with no negatives, which means the other 2 would be imaginary. Okay, so imaginary numbers always come in pairs, and so that is why you count backwards by 2. Okay, so imaginary numbers always come in pairs. So on this one, this happened to be how it worked out. I had 1 positive and 2 negatives, but I always count backwards by 2s. So if I had counted off that there were 5 sign changes, Descartes' rule of signs would have said a 5 minus 2 minus 2. I would either have 5 or 3 or 1. So that's what you can't see. So that's what you're going to do. All right, the final one is going to be intermediate value theorem. And that's just going to tell me if I've got answers in between anything. So for instance, I know that negative 5 is an answer. Okay, I know that negative 1 is an answer, and I know that positive 1 is an answer. So I can find out, I already know that these things are there, but I'm going to pretend like I don't for a second. So I'm going to try negative 6, and I'm going to try negative 4, and I'm going to see if there's an answer in between them. So first of all, there is, because we've already found it. But I want to figure out what spits out if I shove in a negative 6. So go back to using synthetic division. I've got a 1, a 5, a negative 1, and a negative 5. And I already know it's not going to work. I know it's not going to give me a 0 here. I want to know what it does give me. So drop your 1. So negative 6 times 1 is negative 6. That gives me negative 1. Negative 6 times negative 1 is 6, which gives me 5. And negative 6 times negative 5 is negative 30, which gives me a negative 35. So what did you just figure out? At negative 6, his y-coordinate is negative 35. Okay, so the point, if I look at this as a graph that is not drawn to scale, okay, -6, -35 is on that graph. So now let's try -4. So -4. I got a 1, a 5, a -1. Hang on, you can't see. A 1, a 5, a -1, and a -5. So that's going to be, what is -4 times 1? It's -4. That gives me a 1. -4 times 1 is -4. That gives me -5. -4 times -5 is 20. That gives me 15. So what did I learn? I learned that the point -4, +15 is on the graph. So guess what? What did you have to travel through to get from negative world into positive world? I had to travel through 0, which is your axis. So the intermediate value theorem is a way to test to see if there are answers in between there. Okay? So if you get sign changes, I shoved in this and got a negative, I shoved in this and got a positive. If you get a sign change, you are guaranteed an answer between those two numbers. If you don't get a sign change, you don't know. Okay? So that is your introduction to this lesson. So for the next video, we're just going to race through and do some sample problems.